In chapter 13, I remember that I solved related to critical load of structures. Additionally, we have another subchapter, second formula. This case is when the eccentricity occurs. We apply the second formula. You can see formulation is a little bit complicated. Also, I solved the example about this formulation, but this is nonlinear equation. And you can see I solved this equation by using the software, MATLAB software. It is not practical for hand calculation. Therefore, I want to say don't focus on this subchapter, I want to say, okay. And additionally, we have another subchapter, inelastic buckling. In that case, you may remember that we're taking modulus of elasticity as a constant, but mostly modulus of elasticity is the nonlinear behavior, also like this, okay. In this case, we have a different modulus of elasticity. And then in that case, we are using the iterative calculation. First of all, we calculating the lambda meaning that the slender ratio. You remember that the k is the maybe I want to say that like this. K is this one. Oh, I can't remember the definition of this effective length factor. Sorry, that you know the k. And by using this formulation, we also calculate to inelastic buckling. And also formulation is available in here. And also I can say you can look at this subsection, but not focus on this subject there. In this course, in this lesson, I want to focus on the critical load for design practice. In the book, the different formulation is used because they are using 2 pound and feet units. And also I want to show you, and this formulation coming from the like 1223, they're using for the different units. Therefore, I need to convert to the SI units. I have a, I think, where is my yeah. I found in here, this is the American standards formulation. In chapter E, related to design of the member of compression. Okay. In here, in to most general form, if our steel structure in other, maybe if you have a build-up sections, we have a different formulation. Just I'm talking about the general case. Okay. In general case, we are using this formulation. This is you can see these are SI units. These formulations. Maybe some of you ask me that, Hocam, in Turkish standard, what kind of formulation we will use? Maybe. Do you wonder?
Of course.
Yes? No?
Yes.
Yes. Also we are using the same formulation. About like 5 years ago, in old standard, formulation is different, but after 2016, we started to use the new specification for steel structure, and also formulation, constant, everything is almost same with the American standards. Therefore, if you know the American standards, you have almost known the Turkish steel code design standards. Okay, did you know? I think no. Did you take
Sir, I guess we are using the Turkish standards FCR equal to 0.9 FC.
Yeah, also this available here, like in here, and also 0.9 is the safety factor. It's also available in here. do you think it's...
YDKT, GKT.
Everything is same, okay? This is the nominal force, okay? Also, we multiply by the 0.1 for safety factor, and we are obtaining the design load, okay?
Okay, sir.
Everything is almost same, trust me. Okay, now we are computing this nominal force. You can see the formulation is the E is the modulus of elasticity, Fy is the yield stress. In American standard, American standards, they prefer to use F notation instead of sigma. Okay, yeah, I want to say this was the sigma y. Okay, and also if E, I remember that if E is calculating in somewhere, where is it? If E is, yes, elastic buckling stress is equal to like this formulation. LC is the most important type. LC is the written in here. Where is this? Where is this? Effective length. I'm sorry, effective length. Where is it? Can you see the LC in here? Where's the LC? LC is, I want to say the LC is here, the effective length of the member. And also, in other words, that means that K times L. You remember that K, effective length factor, L is the unbraced length. In other words, if there is no brace between the beam, you can take the length of the beam. But if you put somewhere, for example, another connected members, okay, we are taking to half of or another type of another length of the member. Did you understand? I want to show you in a small example. Like, where is this one? Example, this one. For example, in this case, for like XX direction, okay, effective length is 4. For YY direction, effective length is 8, because on XX direction, like these beams can prevent to, you know, rotation of the column, but there is no resistance for YY axis. Therefore, we can take the length of the column. This is equal to 8. Do you understand what is the meaning of the non-braced length of column? Okay, I think this is clear. If you have any question for this, I think no. It's straightforward. We will use the formulation and we will get the results. Also, I summarize in here, and there's this one, like this. And first of all, we calculate the lambda C by using this formulation. And after that, we check if lambda C is lower than 1.5, we will use this formulation. And if lambda C is greater than 1.5, we will use this formulation. After that, we will multiply with the gross area and we will get to the nominal force, axial force. Okay, I'm trying to select one example for standards. Okay, I'm not. Which formula do you want to use? This is the ready sections, therefore there is no illustration in here. So I can choose one of these example. Like, this is not the ready section. Can I use to example 13/89? Is it good for you? Do you accept this?
Yeah, it's okay.
Okay, so I think a little bit zoom. Okay, not big. Okay, like using American Standard equation, check if a column having a cross section in below, okay, shown at support with the axial force as also given as, and where's the, okay, the column has a length as 4 meter and it's made up to a 992 still, and it's unpinned. Where is the question? Using American, check. Okay, check. We will control if can carry this load or not. Okay, we will check to check criteria. We will design to this section. First of all, I need to find two nominal Pn value. First of all, I want to. It seems to be a little bit dark. Karanlık değil mi arkadaşlar biraz? Görebiliyor musunuz? Nasıl?
Görebiliyoruz hocam.
I guess it's good.
It's good? Okay. Okay. You know, it's the P is 1,500 kilonewton. Is it kilonewton or newton? Let me check.
I guess kilonewton.
Yes. Okay. So we will compute with the, you know, P design is equal to P times Pn is equal to 0.9 Pn, and we compare this. If this value is greater than P, okay, we say yes, satisfy criteria. It's else not satisfied. So we need to find two Pn value. Maybe you remember that Pn is equal to A times F critical. Also F critical value, we have two formulation. Okay, we can say it depends on lambda c. So first of all, we need to find two lambda c value. Lambda c, you can see K times. Can I start the recording? Did I start recording? Açtım mı arkadaşlar kaydı? Did you remember?
Yes, sir, we did.
Okay. Sorry that always I'm forgetting that. That means. Okay. K times L divided by R P. Sorry. Also, I can open this in here. Yes, like this. Square root sigma y divided by E. Okay, so we know in the question, and there's written that A992 steel. Also, we need to look at the properties. Like, what is the property first? I need to check. Like this, I think that modulus of elasticity is 200 gigapascal. I can't remember the sigma y. Let me check the sigma y. Okay. Or maybe we can check on the internet, or we can look at to do another book solutions. Let me. A992 steel field strength, and not the psi value. Yeah, yes, 345 megapascal. Okay, 345 megapascal. So sigma y is equal to 345 megapascal. So also I need a unbraced length. I need to look at the question. They write to column length is 4 meters, and there is no information about bracing. Can you see? Therefore, unbraced length is equal to 4 meters. So I can write L is equal to 4. Okay. Also, K is equal to, you remember that, effective length factor. Is there any information about the boundary condition? You can see its ends are pinned. What does it mean, pin? Both ends in pin. There is meaning that we took the K is equal to, do you remember?
1.
1, exactly, thank you. K is equal to 1 because this is the ideal count. So I found in the formulation K, L, sigma y, E, P, we know, already know. Just only we don't know the R. You know, maybe you remember that I is equal to moment of inertia divided by area. Did you know this formulation?
Mm-hmm.
Okay, so we already don't know what does it mean, the moment of inertia and area, but we can find, isn't it? Because this cross section is given in here. Okay, so our structural shape like this. I want to shape like this. X direction, this one is the y direction. Okay, we have ix and iy value. So which one do we take, ix or iy? Sorry, you can't see
we
the
can
mic.
see.
I'm sorry that. So this is cross section like this, isn't it? So I can compute ix or iy. Which one I will choose?
I guess iy.
Why?
1 point.
I can say which one is the minimum. Okay. Just can you guess? Okay, for example, if you think ix is equal minimum, and if you're sure, hocam, definitely ix is minimum, we don't need to compute to iy, and we can directly take to the ix value. But if you're not sure about which one is lower, okay, I prefer to compute both one, okay, and compare this one. Mostly in general, like these direction, moment of inertia about this direction is larger than like this direction. In this shape, in other words, ix is smaller than the iy, general. But sometimes, you know, you can see height and width is almost same, okay? Therefore, I am not sure which one is greater, ix or iy. But in my opinion, ix is a little bit smaller than iy. So I prefer to compute both ones. Okay, I want to use Excel table instead of, because also I don't have enough space on the board. In addition, it's I can compute much more faster than to hand calculation. Therefore, I want to choose the Excel. Are you okay? If you don't want, hocam, use the whiteboard, I can pass the whiteboard. It's not complicated. This is related to static course, therefore. Like, yes. You remember that. Did you know how we can compute the moment of inertia? Do you have any trouble? Okay. If you have a trouble, I can write the general formulation on whiteboard. Var mı sorunuz bununla alakalı, sorunuz falan? Unuttunuz mu? Okay, I want to say, okay, like ix is equal to like
1/12.
ix prime plus dy squared times area. Iy is equal to iy prime plus, also this is the sigma, because we have more than one numbers, the x squared times area. Parallel extension. Did you remember this one? Hatırladınız mı? I think no one can remember. What does it mean, prime, meaning that? Prime meaning that moment of inertia of the part in local axis, in local centroid, okay? Also, dy is the vertical distance between the system centroid and part centroid. Did you understand? Moment of inertia ile alakalı sıkıntınız var mı? Do you have any trouble, big trouble for moment of inertia? Yes or no? You can see. Okay. Just I can write this. Okay. We have 3 parts. Okay. Like this one is the first part, second part, and third part. Okay. First of all, I want to start with the first part. Like part 1. Okay. Like, just first of all, I want to look at the dimensions. I forgot this one, 20 millimeter and 300 millimeter. Like this one is this one is 20. This one is 3000. Also, this one is 20. 3000. Also, this length is
10.
Kaç?
10 ortası değil mi hocam?
Yes. Thickness is 10. Length is like I'm a little bit confused. Which one is 350? Outer distance is 350. Inner distance is 350. I think that outer distance is 350, isn't it? Inner distance is 310. I think that. Isn't it? Doğru görüyorum değil mi?
Right, sir.
Yes. So this thickness is 10. Okay. This thickness is 310. This length. Okay. Every information is taken. Okay. So I want to write these values on Excel. This is the first piece. Second piece. And third piece. Both ones in rectangles, therefore I want to use the B, H values in here. Like width is the first and second part is the 20. 8 is, you can see, 300. The last one is the last part, the third part is width is 310 and 8 is the thickness is 10, isn't it? Okay, so I want to start with the Ix prime. What is the Ix formulation? Do you remember? E times H cube divided by 12.
12.
Yes. So this is the moment of inertia, x-axis. Okay. What about to y prime? Is reverse one. It's equal to
BH
b cube times h divided by 12. Like this. And also I compute Ix and Iy. So in the formulation, I compute Ix prime and Iy prime. I need to compute the dx and dy. Okay. So what does it mean dy? Dy is the centroid of two piece centroid and system centroid. You can see, for example, centroid of the first part in here, system centroid in here. Therefore, dy1 is equal to 0 because there is no vertical distance, isn't it? Fine. What about the dx1? dx1 is not 0. You know, this is the 10. This is the half of this divided by 310 divided by 2, half of this length plus 20 divided by 2. Isn't it? Did you understand this length? Şunun yarısını alıyoruz ve şunun yarısını alıyoruz. So this one is, I can compute in here. Okay. Also same thing for part 2 because dy2 is 0. Similarly.
Hocam
dy2
orası 300 olmaz mı? 310 310 bölü 2 değil mi?
310 bölü 2 artı
Ha
20 bölü 2.
ben 30 olarak gördüm de o yüzden.
Yok. This is available in here. Sorry for writing. Okay. So for this one, you can see. Also, centroid of the third member, the third piece is in here. Also, system centroid is same location. Therefore, dy3 is equal to 0. dx3 is equal to 0. Okay. So I already computed all values of dx and dy values. So first of all, I want to write the y values. dy is equal to first part, you can see 0. Second part is 0. Third part is 0. And also I need to write the dx. dx is first part is equal in parentheses, no, not parentheses, 310 divided by 2 plus 30 divided by, not 30, 20 divided by 2, and 165. And also, similarly, we have same formulation for dy2 and dx part, so dx2 and dx3 is equal to 0. Okay, so I have found all information. Just only I need to compute also area. You know how we can compute the cross, area of the rectangle cross section is equal to b times h. So alan yetmedi. Biraz daha küçültelim ha. Yes. This is equal to b times and then yes h. So I compute all this information, so I can readily compute to ix. Ix, maybe you can remember that. Ix prime plus dy squared times area. This is ix. Also in iy is equal to iy prime plus dx squared times area. And this is the so I need to get the summation of these values. There is the auto sum in here. So ix is total ix is and total iy is this one. Which one is greater? I think iy is greater than ix, isn't it? This is
Yes, I said.
Yeah, is 90 million. This is the 81 million, like that. Therefore, I should take iy. Because I already know ix is lower, but I need to prove ix is lower. Therefore, I need to take this value. So now I already found to ix value. So I can write what's this value? 900. I think I can.
1283.
I don't want to write in here because
Okay,
I already compute to area in here too. You can see. Also, I can compute to auto sum. This is the area. So
I calculated the array, sir.
Yes. R is equal to Rx, isn't? Do you want to say like this?
Yes, it's same.
So R is equal to Rx. This is the in square root moment of inertia divided by area and
0.07. Yes, like that.
yes, I am using the millimeter, therefore 77 millimeter. So R is equal to 77 millimeter. So also I need to convert to the length as a millimeter. I am is, you know, kilonewton, millimeter units is gigapascal. Yes, this is written as gigapascal. This is the megapascal. In order to convert to gigapascal, I need to multiply by 10 to the power minus 3, like this. So gigapascal, millimeter, kilonewton. Okay, everything is okay. So I can write two values in lambda c. This is also, can I use the exam for computation? You know, lambda c is equal to, you know, k is equal to 1 times L is equal to 4,000. Yes, divided by, I am using the parentheses, R is equal to this value times P is available in here.
51, I guess.
Hazır formül var. I prefer to write the exam. Yes.
Biz tek tek hesaplıyoruz ama hocam ya.
3,14 al o zaman. Hiç yorma kendini. Sınavda zaten o kadar hassas olmanıza gerek yok. Okay. In square root, you can see sigma y is 335 10 to the power minus 3. Okay. Divided by modulus of elasticity 200, and we get to lambda c is equal to, that's my 0.648, blah blah blah. Okay, so okay, you can see it here. Yes. Okay. Now we can compare these. Yanlış yazmışım. Never mind. Okay. Now we can compare with you in the formulation 1.5. You can see it's lower than the 1.5. Therefore, I need to use these formulations. So FCR is equal to, I can move like this. Nereye gittin sen? Okay. FCR is equal to FCR is equal to 0.5, that's 658 times lambda c square. So it's a little bit üzerinin üzeri oluyor. The power in parentheses lambda c. Sorry, I need to, whoa, x. I need to cut. Control X, enter, like equal, Control V. Okay, this is lambda c square, close the parentheses, times 345, like 10 to the power minus 3. So, nerede hata mı yaptık? Okay, this is the gigapascal. So I compute to the FCR. Okay, FCR like this. So I need to compute the PN. PN, you can see A times ACR. You know, where's my A in here? So PN is equal to you can see A times FCR. So you can see nominal force is 421.88. So design force is, you already said, Ahmed,
PN
we can multiply with 0.9,
Mm-hmm.
isn't it?
Yes.
We can times this one. So design force is 379. So we can compare with its actual force. You can see it's, so our design value is 349. Compare this one, you can see this is lower than
P. It's not okay.
So P design is lower than P, so system is not satisfied to load, isn't it?
Yes.
If we didn't make any numerical error, numerical mistake, okay, I don't think so. We need to increase our cross sections dimension. You can see we can increase like 5 times larger, isn't it? We need a 5 times larger area. Bayağı büyük bir araya ihtiyacımız var gördüğünüz gibi. Okay. I hope you understand the example. Did you like this example?
Yes,
Maybe
so simple.
So you can use similar example for steel design course. Did you take a steel structures, steel design? Almadınız değil mi?
Ne hocam? Bir daha
Steel structures, steel design.
aldık hocam.
Aldınız mı? Böyle bir şey çözmediniz mi?
Çözdük hocam. Güvenlik katsayısıyla YDKT ile çözdük.
Similar thing. Okay. All these formulation coming from the buckling termination. Also, you can also find relationship with buckling of the column and design practice. Okay. So I think this is enough for today. Do you have any extra question for homeworks, for other things, for general thing about the course? I think no.
Hocam ödevle ilgili bir şey sorsam